Hey everybody, Hollis Darby here with Army Signal Training, and in this training video we're going to be going over trunking. So obviously I'm trying something a little different this time. I have a little caption of myself in the lower right hand corner of your screen. I don't know, just figured I'd change it up a little bit. It's kind of weird for me. I can kind of in my peripheral see myself talking, which is kind of odd to me, but I'm going to try to bear through it. But anyway, so trunking, and this is only appropriate being that our last video that we released was over VLAN. So of course, natively, we're going to have to go into trunking, and hopefully after this training video, you'll understand as to why. But let's go and get started. So what is a trunk? A trunk is a link that carries traffic for more than one VLAN. Trunks accomplish this by multiplexing traffic from multiple VLANs into one stream of data. They typically connect switches and enable ports on multiple switches to be assigned to the same VLAN, known as end-to-end. Now, if you watched my VLAN training video, which you better have, you'll understand that there's really two different ways of implementing VLANs, end-to-end and local. So in this case, utilizing a trunk between these two switches and having the sharing that VLAN information over those trunks, this is going to be known as end-to-end. But what we're getting at with this is, what is a trunk? It is a physical segment, which is, this black line here is one segment. Within it, I have this red dotted line and this green dotted line, which represent VLAN 10 and VLAN 20. So within that one segment, we're actually carrying traffic for two virtual local area networks. So it's segmenting that traffic together, and we'll talk about how it's doing that here in a second. So the types of trunks. There are two methods of identifying VLANs over a trunk, and those are inner switch link, ISL. ISL is a Cisco proprietary method that encapsulates the original frame in a header, which contains the VLAN information. The second is 802.1q, which is the IEEE standard, and it tags the frame by inserting a field into the original frame immediately after the source MAC address. Now I will tell you, Cisco, although it owns ISL, is throwing it away. In fact, if you buy a newer switch, it won't even be on there. Cisco has completely or officially discontinued the use of ISL. Not that you won't run into it in some of your older model switches. In fact, most of my 3560s here still support ISL because of the older 3560s. Or if you're working out there in the field currently in the private sector, it's not to say you won't see it out there. But if you're using ISL out there in the private sector, you're wrong. Because you should be using the IEEE standard or industry standard, which is known as 802.1q. Mainly because of all the benefits that you get by using it. And essentially, I included this little graphic here from CBT Nuggets. I'm not going to go into the techie component of it as to, what the junk is in here, but just notice it's just junk. I mean, out of all the 26 bytes of data in this header, and most of it is literally junk. I mean, there's some valid information in there, but again, most of it's irrelevant for what we need. But if you look at 802.1q, it has this little 4-byte tag. It just kind of like shoves it in between there, shims it in. And within it, we have the VLAN ID itself, and we also have a 3-byte priority. And this is actually really important to us, because as we go further on into things like wireless or really voice over IP, we're really going to start concerning ourselves with something called quality of service, or QoS. And in that topic, you're going to start covering things like this 3-byte priority, which is going to be your class of service, or your layer 2 quality of service. So anyway, there are two types of encapsulations: ISL, .1q. You will only use .1q. So how does it work? When a frame comes into a switch port, the frame is tagged internally within the switch with the VLAN number of the port. What that means is, as this PC sends traffic, this PC has no idea what VLAN it belongs to, but that switch port it's attached to does. So as that traffic comes in and gets to that switch port tags it with the VLAN ID. When it reaches the outgoing port, the internal tag is removed. So what that means is, as it goes to exit the switch or its outgoing interface, that little tag that this switch port put in there, it pulls it off. And what happens is, if the exit port is a trunk port, its VLAN is identified in either the ISL or 802.1q encapsulation, which checks the VLAN of the frame and adds the internal tag. So again, this PC goes to send traffic. It gets to this port here. This port says, oh, you're VLAN 10. Comes over here to the exit interface. It pulls that little part. It checks. It says, oh, you're VLAN 10. But it's not going to use that tag. It's actually going to re-encapsulate that entire frame in 802.1q, because that's what you're going to use. And it's going to input its own VLAN tag in there. And then it's going to traverse this trunk all the way over here to this other switch. And when it gets to this switch, it's going to decapsulate that, remove its VLAN ID tag, and only forward it to ports that are access to VLAN 10. So in this case, this is the only port on VLAN 10. So as it comes in, decapsulates, pulls that VLAN information out, it's going to do an ARP, or simply look into the MAC address table of the switch and say, oh, that belongs to this PC right here. And I have a little diagram here. Kind of spoke a little too fast. I mean, I spent like 30 minutes with this diagram. I didn't even go over it. But traffic comes in. It's tagged with the VLAN ID. As you know, this is going to be the .1q encapsulation. It's going to tag it with the VLAN ID. It's going to come here. The switch is going to remove the VLAN ID. And then the untagged frame is going to be sent to the PC. So, in saying that, the PCs in this, these two PCs, they never know what VLAN they're on. It's completely transparent to them. And in fact, if that wasn't done, and that VLAN tag was left in that frame and it came down to the PC would actually throw the frame away, because it would essentially look at that frame as being corrupted. So it would just kind of toss it away. So it's actually good that the switch removes that VLAN tag for us, and that's the way it's supposed to work anyway. So how does it work? Continued. If the exit port is a user port, the original frame is sent out unchanged, making the use of VLANs completely transparent to the user and the end device. In this case, we only have one switch. Here's Bob's computer over here, and here's Susie's computer over here. They're both on VLAN 10. They're both on the same switch. So as Bob sends traffic to Susie on VLAN 10, it comes to this switch port. It says, oh, it tags it with VLAN 10. It says, oh, does this MAC address table look up? It determines it's supposed to go to this port here. As it exits, or before it exits this port over here, it removes VLAN 10 from it and then sends the frame down, untagged. So the tag process is completely anonymous to the PC and the user. So configuring a trunk link. Ports can become trunk ports either by static configuration or dynamically via the dynamic trunking protocol. A switch port can be in one of 5 DTP modes. Access. The access port is a user port on a single VLAN. So that's going to be something like your PC or a printer. It's an access device, single device on the switch port. Trunk. The port negotiates trunking with the port on the other end of the trunk link. Essentially you're hard coding that switch port as a trunk port. Non-negotiate. Non-negotiate, the port is a trunk and does not do DTP negotiation with the other side of the link, which essentially says, no more dynamic trunking protocol for me, thank you. Which, by the way, we don't really want to use. Dynamic desirable. Actively negotiates trunking with the other side of the link. It becomes a trunk if the port of the other switch is set to trunk, dynamic desirable, or dynamic auto. So dynamic desirable, think desirable, is desiring to be a trunk. It's like begging the other side to trunk with it. And lastly, dynamic auto. Dynamic auto passively waits to be connected to the other switch. It becomes a trunk only if the other switch requests it via being set to trunk or dynamic desirable. What I want you to do, and I highly recommend that you do, is write down this table right here. Because this table is going to tell you what plus what will equal what. So if you look here, an access port, if you configure an access, say switch A is set to access and switch B is set to dynamic auto, it's going to not trunk. So actually, if you hard code any side, switch A or switch B with access, it is not going to trunk. However, let's skip down to dynamic auto. Dynamic auto in access will not trunk. Dynamic auto on switch A and dynamic desirable on switch B will trunk. Dynamic auto and dynamic auto will not trunk. But dynamic auto on switch A and trunk on switch B will trunk. So this kind of tells you if one side's configured this way and the other side's configured this way, actually how will it negotiate itself out? And we really need to kind of be weary of this dynamic anything or auto anything. To me, if it says auto and you have an option to hard code it, you auto not do it. You should, as a network, code the intent of your network. So the configuration. You configure a port for trunking at the interface configuration mode. So here's an example of the config here. You simply go into the interface configuration mode, you type in switch port mode, and then whatever you want it to be. And I'll show you that here in a moment. If dynamic mode is used, DTP negotiates the trunking state and encapsulation. I'm going to say that one more time. If dynamic mode is used, dynamic, auto, or desirable, any of these, dynamic auto or dynamic desirable, if any of those two are used, the dynamic trunking protocol negotiates the trunking state and the encapsulation for you. So let's say you have one of those switches that support both ISL and .1Q. Well, I already told you, well, you're not going to use ISL, I promise you. But what if it auto-negotiates ISL? Well, now you just introduce something else you're going to have to troubleshoot as to why that trunk link's not working appropriately. So, again, dynamic, auto, you ought to not do it. If trunk mode is used, you must specify the encapsulation first, and then you can go ahead and disable the DTP negotiations. So if I want a hard-coded interface as a trunk port and say, you know what, switch port mode trunk, that's all you're going to be. The first thing I have to do is right here. I have to say what encapsulation mechanism to use, which in our case is going to be .1Q, or in your case too. So, caveat to this. If you're using a newer switch, or a newer switch with a newer iOS, most likely the only trunk encapsulation you have as an option to you is .1Q. And if that's the case, you will not need to input this first command here, because you only have one option. So when you tell it to trunk, it's natively going to choose .1Q. In my equipment, and in a lot of equipment out there in the private sector and in the military, I would safely say, you might have both. It's a pretty common. I mean, like I said, Cisco just years back started phasing ISL out, so you might initially just want to go ahead and try to hard code it as .1Q before you even set it to trunk. But if you forget to do that and both are an option, it's going to give you an error message descriptively telling you why. So let's actually pull up some configuration here and show you how to configure. So I'm going to go into global configuration mode. I'm going interface F0/. Actually, I want to go in interface 5. So I'm interface 0/5. In fact, I'm going to show you how this is set up. There's nothing set up in interface 5. We'll do a do show interface F0/5 switch port to show you everything's still operation mode's down. There's nothing plugged in, by the way. Administrative mode's dynamic auto, so it's sitting dynamic auto. It's as soon as something requests a trunk with it, it's gonna trunk. And we also have trunking negotiation currently still on. So what I want to do is go in and hard code some of this. So the first thing, like I said, switch port mode trunk. If you have two encapsulation mechanisms available to you, .1Q or ISL, you're going to get this error message. And it's going to say, whoa, we don't know what you want to do. It's currently set to auto. You need to basically manually configure, are you going to be ISL or are you going to be .1Q? So the first thing I need to do is go in and type in switch port trunk encapsulation and which encapsulation I want to use. And as noted earlier, my 3560 actually still supports both ISL and .1Q, but I'm going to choose .1Q. After defining the encapsulation, now I can go in and say switch port mode trunk. And because I'm already trunking and I'm hard coding this as a trunk, why even use the dynamic trunking protocol anymore? So I'm going to type in switch port non-negotiate, which will turn off DTP on this interface. And there you have it. That is how you set up the trunk. So if I go in and I do a show interface F0/5 switch port now, I will see that the administrative mode is now trunk. Now earlier, if I scroll up, it was dynamic auto. But now it's trunk. The operation mode is still down because, like I said, I have nothing plugged into this thing. But look at here. Administrative trunking encapsulation is now .1Q. As for up here, it was still just trying to negotiate it. So as you can see, hard coding the interface only and will only benefit you on multiple fronts. One, it will definitely save you a lot of headache and troubleshooting if you left it up to auto negotiate. And two, it's going to help you on the security standpoint as well. So let me pop back over here to the PowerPoint. To be continued. I went a little too fast. So I actually want to demonstrate to you some of these auto assignments. And what I mean by that, I'm going to go back to this chart here. I've pre-configured a couple of these interfaces, or I'm sorry, these switch port modes on a couple of my switches. I'm going to toggle between those and try to trunk between them so you can see what actually happens. In fact, just to alleviate time, I'm only going to do two. So let me pull up my hyperterminal here. And I'm going to show you show run interface F0/1. F0/1 on switch 1 is set to switch port mode access, and if I go over to switch 2, it's also set to access. So if I plug a cable in between switch 1 on switch 1, or port 1 on switch 1 and port 1 on switch 2, I should get a status message here shortly. And let's see what happens. We'll do a show interface F0/1 switch port. Boom. Alright, so switch port is enabled. It's static access. The operation is static access, which is just another way of saying switch port mode access. Look down here, negotiation of trunking is turned off, which means it cannot be a trunk port. And the administrative trunking encapsulation also is still negotiation, but we know it's not going to negotiate a trunk port because the negotiation of trunking is off. Now, let's do a show run interface F0/4. So, on interface 4, I have dynamic desirable on this switch. Let's hop over to the other switch and see how that one's set up. Nothing. Okay, so that's fine. So on switch 1, this is the default configuration for it. In fact, to reinforce that, I'm going to go into config T. I'm going to factory default interface F0/4. Boom, factory default configuration. But on switch 2, as we saw up here, it was set to dynamic desirable. So I'm actually going to reach over and I'm going to plug in port 4 on switch 1 to port 4 on switch 2. Now let's see what happens. Wait for the statuses to come up. So I'm going to do a show interface F0/4 switch port. Wow, look. Switch port enable, great. The administrative mode is dynamic auto. We knew that going into it. That's the default setting for this particular switch. But look at here. The operation mode is trunk. It's going to negotiate the encapsulation. It did negotiate the encapsulation, and here's the sad part. It negotiated ISL, which we know we're not going to use. You know, negotiating trunking's on, yada, yada, yada. So I hope you see what I was trying to demonstrate here, and that is this. Depending on what model switch and the iOS that's in there will depend on what administrative mode it's going to default to. Most of my switches default to dynamic auto. Some of my switches default to dynamic desirable. So if I hooked a cable between the two, or let's say I was a rogue user and I brought my own switch and I hooked into the wall jack at the office, who's to say it doesn't negotiate a trunk, which just open up a huge security hole in your network. So we want to hard code all of this, and knowing what will negotiate what will definitely help you in that, and also knowing and utilizing that best business practice of hard coding everything will alleviate so much troubleshooting in the long run. So I guess now I can go back to the slide. Oh, let me show you a couple commands real quick. We just did the show interface F0/ whatever the interface of question is, switch port. That's a good show command. It gives you a lot of switch port information, but as you can see, you can look at the administrative mode, operation mode, you know, how it negotiated, all those good parameters. Another good one is show interface of question. So in our case, interface 4, followed by the trunk command. And what this does, it says, okay, the trunk, F0/4, it is still set to auto. Its encapsulation is ISL. The status is it is actively trunking, and because we're using .1q, we're not using .1q. The encapsulation is ISL, and the native VLAN here actually is irrelevant. The native VLAN only comes into play if you're using .1q. But I'm going to go in real quick. Just to show you how quickly it can change and how much control you can have over your network. Type that in. That's going to take effect. Now look. So I know I did it really fast, but essentially I just went into interface F0/4, the interface that we were doing the show commands for, and essentially I said, hey, look, bud, your encapsulation mechanism is going to be .1q, and you will be a trunk. Not dynamic auto, you will be a trunk. So now when I issue that command, show interface F0/4 trunk, I can see, hey, F0/4, your mode is on, i.e. you are trunking. The encapsulation is 802.1q. Your status is trunking, and your native VLAN on the trunk is VLAN 1. We're not going to cover the native VLAN. Lastly, you can do a show interface trunk. This is going to scan your entire switch, and what it will end up doing is, depending on how many, let's say I had 4 trunk ports. All 4 trunk ports would show up here and will show the VLANs that are allowed, etc., etc. So the 3 commands that you can use, show commands you can use real fast is show interface, whatever the interface is, followed by switch port, show interface of question, followed by trunk, or simply show interface trunk. And that's it, guys. So in closing, I would like to thank everyone for watching this video. Thank you for your continued support on Army Signal Training. If you haven't already, please like the Army Signal Training Facebook page. I appreciate the support, and I look forward to making the next Signal Training video. Have a great day.